Hello students, and welcome to the continued lesson on finding asymptotes, and particularly horizontal asymptotes. That previous video should have ended at this point up here, and we're looking at some examples here of finding horizontal asymptotes. And we're going to use both a graphical and an algebraic method to help us solve this. We really have to use both. Um, so let's take a look at the leading terms. Okay, so that's the terms with the highest power of x. Look at leading terms. The reason we do that is because we care about what happens as x approaches infinity. What's going to happen to this entire expression here when x gets really, really huge? Well, these little guys here, 3x and minus 5, it is insignificant compared to x squared. When you have a really big number squared, it dominates everything else. So in the long run, this function is going to behave like 2x squared on the top, and it's going to behave like x squared on the bottom. So if we take a look at this, you get 2x squared over x squared, and that's going to simplify to 2. And so that's going to suggest to us that 2 may in fact be the horizontal asymptotes. To be sure, or to get a better idea, we really need to use our graphing calculator. So actually, let me clear out all of this other stuff here, since I don't really need it anymore. Don't want to confuse anybody. Clear this out. Let's see if I can pick a different color. And then hit graph. And as this is graphing, I want to remind everybody again that what we care about is the behavior as x goes towards infinity and as x goes towards negative infinity. We don't worry too much about what happens in between. That's what a horizontal asymptote tell us. And so you can see here that there seems to be a gap in here, and there's probably an imaginary line at 2 that goes through here, and that satisfies the definition of horizontal asymptote. But that's not enough just to look at the graph and see that. Now let's actually put in some big values, big numbers, and see what happens. So I want to show you how you can go into your table set, hit the second button, and then the window button, and see how I have my independent variable set to ask. That'll allow me to type in a value for x and instantly get a value for y. Yours might say auto here, so you won't be able to do this, so make sure you change your independent variable to ask. So now I can go into the table, and you can see I typed in a gigantic number like 1,000,000. Yeah, that's 1,000,000. And it shows that y is equal to 2, but when I scroll over, it's clear that that's just a rounding error. It's actually 1.9999. In other words, as x right here in the graph gets bigger and bigger, y gets closer and closer to 2. Never quite there, but it gets closer. Okay? Same thing if I put in a big negative number, like let's try negative 1,000,000, so that's 100,000. No, let's go for 1,000,000. Hit enter, and you can see a similar result, but it's not quite. It's not quite 2. It's 2 point something with a bunch of decimals, because it's never actually going to reach 2. Okay, so then we can conclude that y equals 2 is the horizontal asymptote. Now I want to take this discussion a little bit further and say, can we find the range? Okay, and if you recall, the range is the list of all possible outputs. Okay, so range is the list of all possible outputs, or in this case, all of the possible y values. Well, what y values is possible in this graph? You can see here that as we get closer and closer to x equals 2, this graph shoots straight up. So you're going to cover every single y value in the positive direction, and then you're going to cover every single y value in the negative direction. It's going to shoot straight down here. But there is a gap in between here that it will never actually reach. So we can say that this is all real numbers except 2. Once again, it's going to go up really far, it's going to go down really far, but at 2, it's never actually going to reach that point, because that's one of the asymptotes. And let's write this in interval notation. So it's everything from negative infinity to 2, and then everything from 2 to positive infinity. So it can be everything except 2. And you can see that there's a correlation here between horizontal asymptotes and range. Now I do have to warn you, this correlation does not always exist. Sometimes the graph can cross over parts of the horizontal asymptote. So it's very close, but you really have to think about it. You really have to show the graph. You have to check the table and the values and actually to be sure about this, okay? And there's a lot of examples where there aren't any vertical asymptotes or horizontal asymptotes at all, but then we can still find the range. So now let's be careful with that. Okay, now I'm going to continue and look at a couple more complicated examples. So here I have an example, x over x squared minus x minus 2. And we're going to follow sort of the same idea that we had before, where we have to look at the leading terms. And the leading terms on the top is x, on the bottom is x squared. So you have x over x squared. That's going to reduce to 1 over x. And what's going to happen to this as x approaches infinity? As the denominator gets really, really huge, the entire fraction is going to approach 0. So as x approaches infinity, 1 over x is going to approach 0, because you're going to keep on dividing by a bigger and bigger number. So that would suggest to me that the horizontal asymptote here is 0. And let's check that with our graph. So I can go into the graph here. Let me clear out this example and just do 1 divided by x squared minus x minus 2. Oh, I'm sorry, it should be x over x squared minus x minus 2. And you can see my window here. Okay. And you can see that as x gets closer and closer, or bigger and bigger, it seems to touch the x-axis. Well, that's really not the case. To see that, we can go into our table, and we can see that if you type in a really big number for x, y, you get a very small number. And same thing here, if you type in a very big number, or big negative number for x, you get a very small number. This is negative 9.999 times 10 to the negative 7, so this is a very small number. So I think our intuition is correct, and we can say that as x approaches infinity, the value of f of x gets closer and closer to 0. And so we can say that this is, in fact, the horizontal asymptote. Now, what about the range? We saw last time that the range, so is the range everything except 0? Well, let's look at the graph. See, this is one of those things that's tricky about range and about domain as well, but particularly range. You see the horizontal asymptote here, which is the x-axis. Let me turn this on here. The horizontal asymptote here, which is the x-axis, And that holds true for the right side of the graph as x gets really, really big, and it holds true for the left side of the graph as x gets really, really small or very big in the negative direction. But in the middle here, you have this thing that comes down and just breaks right through. And in fact, if you type in trace 0, you can see that it is possible to get 0, 0. And this piece here in the middle of the graph, it covers everything, all the way up to positive infinity and all the way down to negative infinity. So the range here is actually all real numbers. Everything from negative infinity to positive infinity. Oops. The range here is everything from positive or negative infinity to positive infinity, or in other words, it's all real numbers. So this is one of the cases where the range and the horizontal asymptote does not match, and we have to use a lot of our logic and we have to reason our way through this in order to see this, because it's not always the same. It may be like that in some of your simpler algebra classes, but that's not going to be the case in pre-calculus, and it's definitely not going to be the case in calculus. And one final example with horizontal asymptotes and range. So this time, take the lead terms again and get 3x squared over 2x. And this is going to simplify to 3x. And so as x approaches infinity, 3x also approaches infinity. As x gets really, really big, this number gets really, really big, and the whole thing is going to get really, really big. And so this suggests to us that there is no horizontal asymptote. Okay? In other words, the horizontal asymptote is infinity, which is another way of saying that it just simply doesn't exist. Okay? And let's look at our graph and try that. So we can go into our graph. Let's clear that out. Make sure we use parentheses. 3x squared minus 2x plus 8 divided by quantity 2x minus 3, and hit graph. Oh, I wonder if I goofed here. Okay. Oh, there it is. Starting to come through, and you can see a little bit of a tip here, so that means I just need to make my window bigger. So let's go into the window. Let's go all the way out to maybe 100 this time. And then graph. And you can see my window down here. If you didn't quite catch it, it'll update in just a minute. And this is fairly computationally intensive, so it might take a minute for my calculator and my computer to draw it there. And I know this looks a little bit weird, but this is a sort of an upside down V that just shoots straight down to the bottom, and the same thing is happening here at the top. And if we want to confirm this, all we have to do is go into our table. And if you type in a really big number, you get a really big number. If you type in a really big negative number, like this, you also get a really, really big number. So in this case, there is no horizontal asymptote. So I'm going to say no horizontal asymptote. And one final question about this is, what about the range? Does that mean that the range is all real numbers, like it was before? So you can see here, all the y values, it definitely goes down forever. It looks like it goes up forever, but there seems to be just I think I made a mistake. Hold on, let me go into my window here and rectify. I don't want the x values to be that big. I want the y values to be that big. Yeah, that would explain a lot. So I want the y values to go from negative 100. Now this will help me see a little bit clearer. There we go, you see? So you can see here that the values, there's a vertical asymptote here that shoots straight up and down, but there isn't really a horizontal asymptote because this curve here goes downwards, this curve here goes downwards, and as x approaches infinity, this curve is going to go towards infinity. As x approaches negative infinity, this curve is also going towards negative infinity. So the range, well, there does seem to be a bit of a gap in here, and so the best way that we can find the range is to find the min and the max. So I can go into finding the minimum. I actually don't want that. I want the minimum to be here. It looks like it's about 1.5. Okay, and then the right bound, let's move it a little bit closer. Move it about right here. Have it take a guess. And I get that the y value at its smallest is about 9.88. And then let's do it for this little tip right here. This time looking for the max. And let's go from, let's say, 0.5 on the left side. And then just a little after that on the right side. And so it's about negative 3.87. So between negative 3.87 and 9.89, there's a gap there where there are no x values. There are no y values in there. So I can say here that the range is everything from negative infinity to negative 3.87, or everything from 9.89 to positive infinity. And this will help me get my answer. And notice here, this is an example where the horizontal asymptote doesn't exist, so it's got nothing to do with the range. The range is something completely different that we need to find using the max and the min values. And I will end this video here. There's one more video quickly on even and odd functions.